Hello, this is the lecture for section 3.4, the factor theorem and the remainder theorem. In the last section, we looked at finding the zeros of a polynomial from the factors, and then using the factors of a polynomial to find the zeros. In this section, and we were just looking at easily factored polynomials. In this section, we're going to take a look at that further, which will lead us into the factor theorem and the remainder theorem. All right, suppose we know that x equals -2 is a horizontal intercept, or a zero, of the polynomial x cubed plus 8. Then we would know we could factor x cubed plus 8 into x plus 2 times something. Well, how do we find out what that something is? Of course, polynomial long division will do that. All right, you could also use synthetic division. I think your text has some examples of synthetic division. If not, you can Google it. I don't like synthetic division, so I'm going to use polynomial long division, and that's what I'm going to show you now. All right, for polynomial long division, we want to set up the division problem. So let's see, we're going to be dividing, what is our factor that leads to the zero? X equals -2 is the intercept, so x plus 2 is the factor. So we're going to be dividing our polynomial x cubed plus 8 by x plus 2. All right, now I'm going to set up a division problem here, and I want my terms in the polynomial to be in descending order of the exponent. And this polynomial, it doesn't have an x squared or an x term. So you know what we're going to do? We're just going to say it's 0x squared, because that's just 0, right? Plus 0x, and then plus that 8. Okay, now to do the long division here, we only want to look at the first term of the factor we're dividing out. All right, and we want to see how many times does x divide into the first term of the polynomial, x cubed. How many times does x go into x cubed? It goes into x squared times. All right, so we'll put that x squared up here in our x squared column. Right, now multiply our 0 by our x squared. So x squared times x is x cubed. All right, then x squared times 2 is 2x squared. All right, we're going to subtract that out. X cubed minus x cubed, of course, is 0. And 0x squared plus or minus 2x squared is going to be -2x squared. All right, bring down that next term, which just happens to be a 0, or 0x. All right, how many times does x? And then we're going to divide again. How many times does x go into -2x squared? Well, -2x times. So that'll go up there in the x column. All right, and -2x times x is, of course, -2x squared. -2x times 2 is -4x. And then we'll subtract that out. Right? -2x squared minus -2x squared, of course, is 0. 0 minus -4x squared is positive 4x. Oops, not 4x squared, 4x. There we go. All right, now bring down this 8. Okay, and and now divide again. All right, x goes into 4x, x times, so let's say plus x up there. All right, and x plus 4. Silly me. There we go, plus 4. All right, so 4 times x is 4x, and 4 times 2 is 8. All right, subtract that out, and we see that the remainder is 0. That, of course, is what's expected here, because we knew that x equals -2 is a horizontal intercept, or we thought it was, right? So here's something else. So we've now effectively factored the polynomial x cubed plus 8 into x plus 2 times, what's that? X squared minus 2x plus 4. All right. Now say we wanted to find all the zeros of this polynomial. Let's call it p of x. All right. Say we want to find all the zeros, we would need to continue to keep factoring we need to continue to factor this x squared minus 2x plus 4. All right. Well, that one does not factor, but it is quadratic, so we could find those zeros, right, by setting this prime trinomial equal to 0 and solving. Forget that. The quadratic formula would have to be used for that. I won't run through all the calculations here. I do have that programmed into my calculator. So let me just go ahead. And by the way, if you're taking a pre-calculus, you don't have to use the quadratic formula by hand. Go ahead and program that into your graphing calculator. You can Google how to do that. Be a video for you. All right, so let's see. A is 1, B is -2, and C is 4. I have two solutions here then. 2. So x equals 2.732 or 0.732. Okay. All right. Let's do one more example. Okay. Say we know that x equals 8 is a 0 of the polynomial listed here, x cubed minus 24x squared plus 192x minus 512. Find the rest of the zeros. Well, let's first divide out that first one that we know. A 0 of x equal 8 comes from a factor of x minus 8. All right, so we want to divide the polynomial by x minus 8. All right, so we're dividing x cubed minus 24x squared plus 192x minus 512 by x minus 8. All right, x goes into x cubed, x squared times, put that x squared up there, multiply it back out. We have x cubed, -8 times x squared is minus 8x squared. All right, let's subtract that out. X cubed minus x cubed, of course, is 0. -24x squared minus -8x squared is -16x squared. All right, let's bring down that 192x. X goes into -16x squared, -16x times. All right, multiply that out. We have -16x squared. -8 times -16 is positive 128x. Okay, subtract that out. Where's the 16x squared? Subtract out. Now 192x minus 128x is 64x. Bring down that -512. Right, x goes into 64x 64 times. So then we'll subtract out 64 times x, and 64 times -8 is -512. And as expected, the remainder is 0. Okay. So far, this is what we've got. We've got this partially factored. X minus 8 times x squared minus 16x plus 64. Can we keep on factoring with this? We're left with a quadratic. That's good. And yes, we can keep on factoring. Look at that. That looks like a perfect square trinomial. So this is going to factor into x minus 8 times x minus 8 times x minus 8, right? Or x minus 8 cubed. Okay, so there's our p of x. So then what are the zeros of the function? Well, there's only 8. It's 8, right? But it has a multiplicity of 3. but there's only one 0. 3 would be our multiplicity. So if we're to graph this, then what's going to happen at that 0, where it's 8? Well, right at that 0, if we were graphing a very rough sketch, it's going to resemble the cubic function, right? It's going to linger just a little bit. It's going to look like that, right? That's going to be right at the 0, x equal 8, right? So long division, you can also use synthetic division, don't care which. That leads us very nicely into these very important yet very common sense theorems. The remainder theorem, which simply states that if you have some polynomial of degree 1 or greater and some real number c, when you divide that polynomial by x minus c, the remainder is p of c. Right? What is that saying? Well, it means if they divide evenly, there should be 0, right? Let's go back and look at that last example. We knew that 8 divided evenly. It certainly did. So what would p of 8 be? Should be 0, right? Plug 8 in for the x. We'll use the long version of that, right? It's going to be 8 cubed minus 24 times 8 squared plus, I'm going to run out of room, so I'm going to come down, 192 times 8, and then minus 512. Put that on my calculator, that should be 0. Let's run that in. And I'm going to switch the screen to the calculator. I'll let you trust me. You can run those calculations and see that it's 0. All right, so that's the remainder theorem, very common sense, right? The factor theorem also is quite common sense. It just says that if some polynomial is non-zero polynomial, then the real number c is going to be a 0 of that polynomial if and only if x minus c is a factor of p, right? We, of course, already know that because that's how we find the zeros. We set an equation equal to 0, we factor it, and then use the zero product principle to find those zeros. All right, that's it. That ends the lecture for section, what are we at, 3.4. And there's your remainder theorem and your factor theorem.